Hi, and welcome to Making Binary super easy. In this video, you're going to learn how to convert from binary to decimal and decimal to binary and get those numbers in less than 5 seconds. So let's go ahead and do our first number. We're going to go ahead and do a simple number like 21. So let's see how fast we can get this one. The 8-bit binary number for 21 is 00010101. That was pretty fast, right? That was like lightning fast. Why is that? Because all we had to do was just add two numbers. 16 plus 5 is 21. And the associated binary numbers with 16 and 5 is 0001 and 0101. That's how fast we got our number. Now, before I teach you, the rest of the table, I'd like to at least get you familiar with the table. With some of the terminology and things like that. So up here, we got bases of 16, multiples of 16. And we got 8 on top, and we got 8 here. So there's a total of 16. Now, why multiples of 16 and why 16 of them? Well, because we're dealing with 8 bits. Here's 1, 2, 3, 4, 5, 6, 7, 8. So in 8 bits, the total number of possible combinations of zeros and ones is 256. So 16 times 16, here 16 times 16 is 256. So if you do 16 bases or multiples of 16 with 16 range numbers from 0 to 15, so 16 times 16, this right here will allow you to get all 256 combinations which range from 0 to 255. Okay? And the reason it's 0 to 255 as opposed to 256 is because if we started with 1, it would be 1 to 256. But we're starting with 0, so it's 0 to 255, and the same applies to the range numbers. Okay. So now that we know that we can get all 256 possible combinations, let's go ahead and let's do another number, same one in the base of 16. We're going to do the number 19, but we're going to be putting these numbers down here. So number 19, you do 16 times 3. The first thing you do is you need to find your base. 19 is between 16 and 32. And so you always choose the smaller of the two bases. In this case, it's 16. So this number here, you're going to activate it down here, just like this. This number is the same as this number. So you already got half of your numbers. Now, all you have to do is, you know that the target number is 19. You see this over here? Target is 19. 16 plus what number is 19? Well, 3. Well, the associated binary number with 3 is this one here. So you activate it right there. So now you've got your whole 8-bit number just by adding two numbers and finding the associated binary numbers. Okay, so now I'm going to show you something very exciting. It's how to get these numbers, special numbers. You'll be able to get these like in 1 second. Let's look at number let's say 85. So 85 is in between 80 and 96, right? So what's the smaller base? Well, the smaller base is 80. Now, if we wanted to find 85, well, it's in the same try box. 80 plus 80, yeah, 80 plus 5 is 85. So the associated binary of 80 and 5 is 0101. So you do the base first, you activate that, and there it is. This number is the same as this number, and guess what? This one here, it's going to be the same number because it's in the same try box. So that goes the same for all of these numbers. If you wanted to find 17, you just do 16 plus 1, and you find your number, 0001, and then you just say it again, 0001. That's your number. And that's the same thing for all of these. 255, 240 plus 15, they're in the same try box. So all of you that are in the computer world, you know that 1111 is 255. Okay, so now what we're going to do, now that you know how to use this table, I'm gonna show you how to build this table so that you can use it, and it only takes about 1.5 minutes to build a whole table. So let's go ahead and build the table. All right, so everything's pretty straightforward except for the binary numbers. We're going to use roots for that, and we're going to place these roots systematically where the binaries go. And once I show you how to do that, you're going to think to yourself, oh my god, that's so easy. You put them like in 30 seconds. All right, so let's start with a 0. You'll put 0 here, and the next number obviously is 16, because these are multiples of 16. 16 plus 16 is 32. 32 plus 16, 48, and you do that all the way to 240. If you're going to be using this often, or you're going to be testing, I would recommend that you just memorize the multiples of 16, put them on there, and that way you can build your table like in 1.5 minutes. Otherwise, you could just add 16 to each one. And then the range numbers, pretty straightforward. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's pretty straightforward. But now we want to focus on the roots. So the roots here, they're in black, and the branches are in purple. They're the same number. So there's only from 0 to 3. Okay, 1, 2, 3, 4, 1, 2, 3, 4, from 0 to 3. All right, so I'm going to go ahead and activate them. You're going to put these in a systematic order. We'll do the roots first, and then we'll do the branches. Check this out. This is so easy. 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1. And then we'll do 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1. So these 4 roots, 0, 0, 0, 1, 1, 0, 1, 1, we just did half of the binary table right there, just by doing these 4 roots. Now we're going to put the branches. Each one of these roots has one of these branches. So let's go ahead and put the branches in there. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. We're done with the table. Just like that. I mean, this table is so easy to build. It's systematic. And so it's very, very simple. So now that you know where your roots are, you have to know that this quadrant here is quadrant R00. So that means your root 00 goes in this quadrant. 01 goes in this quadrant. 10 goes in this quadrant, and 11 goes in this quadrant. So now that we know that, let's go backwards. Let's do binary to decimal. Okay, this is going to be really, really easy. You got the binary number 1001 0011. Now we know that these 4 are in the base, these 4 are in the range, so we always do the base first. Okay, so the first thing I want you to look at is the root. Well, here's the root, 10. Well, you don't have to look everywhere in the table. You know that 10 is one of these 4 numbers. Okay, and then you look at 01. There it is. So you found your base. That's 144. And you put it right here. So now we got to find our range number. Okay, so our range number is 0011. Well, we got a root of 00. Where's 00? Oh, 00 is up here. So we just have to look in this area. And then you look for your branch. 11. Oh, here it is. So the number is 0011. Oh, okay. So that's range number 3. Okay, so you put number 3. So 144 plus 3 is 147. So this 8-bit binary number is 147. We're done. That's simple. So now that you know how to convert from decimal binary and binary to decimal, and you know how to build this table, you are ready to start practicing and getting these numbers in less than 5 seconds. And you can actually make a, say, like a business card out of this table here. And remember that the table is only here. All of this other stuff is just, instructional. It was just for me to help you understand this. So it's just this table, and you can make a bookmark out of it. And yeah, very simple. So thank you very much for watching. It was an honor, and you guys have a good day. Bye-bye.